All right, let's get started. So I think this is my let's get started, guys. Okay, I think this is my last presentation. So that's it's been fun talking to you all, but I'm also excited to be able to rest my voice. But the last thing I think we're going to talk about, with me at least, is ecosystem and economy. This is just supposed to be a way for us to take a look at, kind of more explicitly, the value or the use of the dot token within the ecosystem, and then some of the ways that's being used, some of the like game theoretical mechanics around the dot token, and then even broader, like looking at the overall ecosystem, like what kind of parachains exist, what kind of entities exist, that kind of stuff. And a lot of this stuff you've heard already, but I think we'll go into some more details or reinforce some ideas. So again, as always, if there's any questions or anything, let's take the conversation in the direction you want to go. But there's a bunch of different things we can touch on, and really like starting off points for talking about ecosystem and economy in Polkadot. Okay? So this presentation will give you a high-level overview of the ecosystem and the economy of the Polkadot network. Obviously, this can't be fully exhaustive, and things are changing every day. But we're basically touching on a bunch of different topics, and just going a little bit deeper into them and shedding lights on those previously unknown areas. So first, we're gonna start with the economy. So there's this thing called the dot token, right? As you learned when you were playing with, making palettes, the dot token can be in one of three states. It can be transferable, it can be locked or frozen, that's the same, and it can be reserved or held. It's basically the same thing, right? And the idea is transferable. It's fully transferable. You can move the token around. You can transfer it around. It's fully liquid. A locked token, a locked and reserved token. Those are both tokens which you own. They belong to you, but they're in a state where you can't transfer it. As we saw, locks are things that can stack, right? So you can have many locks on the same tokens over and over. And reserves are specific chunks of tokens which are reserved for a specific use case. So those are additive, right? And I think this is the same slide I had when I first explained about locks and holds. Again, the best way to understand the behavior here is write some simple tests inside of your code. Just do a lock, do a hold, see what happens. That's the basic idea. So this leads into the idea of, what can we do and solve with these primitives? So one of the biggest problems in blockchain scaling is storage bloat. This is a problem that's plagued both Bitcoin and Ethereum. It's plagued many newer chains now, and if in many chains that haven't solved this problem, they're just kind of like digging themselves a grave, because eventually they're gonna get into this problem with storage bloat. And this is the fact that basically, if we consider the cost, like let's look at Ethereum as a perfect example. Let's consider the cost of storing data on Ethereum, right? So when you make that transaction to store some data, whether it be a contract or whatever information you want, there's a one-time gas fee based on the amount of data stored. That kind of makes sense. But once it's placed on the network, it lives there forever. There's no additional costs, right? There's no taxation on that data. So over a long enough period, the cost of storage will basically reduce to zero, right? If you want to store some piece of data, forever, the best thing to do is to put it on Ethereum. You're going to pay some upfront heavy costs, but at that point, it is storage forever. It is literally on the blockchain forever. You can always access it. And this isn't always good, because truthfully, a lot of data is pretty useless. A lot of data people put on there, and it's never used or touched or read again, and that's not very useful, right? So basically, you worry about basically chains getting storage bloat and growing over time, where there's a bunch of data which is just slowing it down and not actually being helpful. So in Polkadot, we solve this by taking storage deposits. So what we normally would do, so this is in terms of reserve balance, what we normally do for any data you store on the Polkadot blockchain, we take from you a little deposit, we reserve some balance from you, and we basically say, as long as we have this data on our chain, this balance that you own is held by us. If you want this balance back, if you want to transfer it or whatever, you must clean up this data from the blockchain, and then we'll give it back to you. So some people, when they were doing their frame exercise, they saw some code or whatever and implemented this. Like maybe when you made a new proposal or you made a new whatever, kind of anytime a user would store some data on the blockchain, you normally take a deposit, right? And the whole idea again is that there's now an economic incentive for the user to actually go back and clean up their data. If they have a few bucks, maybe a few $100, depending on how big the data is, on that they want to get back. Again, it's not that they ever lost those tokens. It's just that they don't have access to the liquidity of that token until they remove the data from the blockchain, right? So this can be a very good source of like behavior and game theory. And specifically, especially when we're thinking about like making functions where, maybe it's permissionless. Anyone can clean up data. These users are incentivized to go around and actually clean up their own data or clean up other people's data, etc. Right? The other idea before storage deposit, I don't think I talked about it, was storage rent. So this is another idea that I think was propagated around the Ethereum or smart contract communities. Storage rent is very difficult. The idea is that rather than just having a deposit and you get it back, that if you have that on the blockchain, continually you'll get like a fee charged to you about the data you have, right? So they're basically really saying if you want to stop getting this fee charged to you, then clean up the data, right? But this is very difficult to program, right? Imagine you have to go through all data, take the fee from each user. It's like this is very like unbounded complexity problem. So in many ways, actually, this storage deposit system actually kind of works in a way like this fee system, but it's like an inverse economics. So instead of the fact that you are constantly losing fees over time, the best behavior of this storage deposit is that you can't stake those tokens. So you're missing out on the opportunity to inflate your token to get that reward. So if you almost think about it, like I have this token, I have option one, which is using it to back some storage, and that token just stays fixed, right? The other option is I can put it in staking system and earn 10% rewards on it, right? And now I'm growing. That is basically if you change the perspective, you storing that storage into the system and not getting the interest is basically like losing 10% fee every time period, right? So it is almost the same economy, and so this kind of storage deposit system makes sense in an inflationary token world. Yeah, could we get a mic? This is called ecosystem and economy. Okay, I think that was it. Any other questions so far? Okay, I think that makes sense, right? That's the idea. And again, if you had a token which doesn't inflate, this maybe not be as a effective solution. But within Polkadot, this works. And I do think right now you have to manually do all the storage deposits. I think it is on the roadmap of the Frame team to make storage deposits something that's kind of like integrated in the system itself, right? Like you just store some data and automatically we take a deposit from the user, stuff like that. But that's to be programmed. Okay. And again, more bloat on the system, right? So if we think about this idea of storage deposits, then we can really think about the existential deposit as a storage deposit. It's the same thing. The existential deposit, this requirement that all accounts must have at least this much balance, this is the storage deposit for us holding the basic account information on your chain. So if your account information has tons and tons of data by default, you might want to think about actually having an increased increased existential deposit, right? Now again, these kinds of systems, you can always tweak it. There's no way to say, okay, if you have 5 bytes, you must charge exactly $5. Like that's not the way that ecosystems work. That's not the way the economy works. You kind of roughly get an idea. But the idea, I guess, in Polkadot is that if you want to have an account in the system, you must own at least one dot, right? And that guarantees that we will hold data in the Polkadot ecosystem. That means you can hold tokens, you can get an identity, you can stake, you can whatever with that existential deposit. But the whole idea is that existential deposit is a storage deposit. It is not some kind of system that we created for no reason. It is literally in the same vein of just we will store data for you if you ensure that you have enough economy behind it. And if you want to transfer your one dot out of your account, the last one dot, we clean up your account. Exactly the same thing, right? Okay, I want to clarify. It's really important, especially in this very crazy world. Not all tokens are equal. Dot truly is a utility token, and I would like to convince you of that in this in this slide. But many tokens they say that they are a utility token, but actually have very little to no utility at all. Okay, but let's start with how dot is a utility token. Do I have more slides on this? Yeah. So the main idea here, that this is the short level summary. First, you must be convinced that getting access to flexible, secure block space is valuable, right? That there is a computer out there, this Polkadot, ubiquitous computer, where you could upload some data or upload this parachain WASM logic, and you can basically have it be secured and execute. If that is first, we would establish that is valuable. Okay, if that is valuable, then you must realize that the only way to get access to that block space is with dot token. Can we get a mic over there? Oh, yeah. So let me finish that. So the only way that you can get access to that block space is by using the DOT token inside of the Polkadot economy and purchasing it. That's through auctions, through core time, through these, auction systems, whatever. That means the DOT token has some value. I don't know what the value is, but it is tied to the utility that the world sees about getting access to this ubiquitous computer. Then if the DOT token has value, we can then use that value to encourage behaviors and systems, which is what staking is, right? We can allow people to identify, stake, and secure the network using this value as a backing of that, right? And if you do bad things, you get punished. You lose that token, which gives you access to value. And then on top of all that, we can also use this value and ownership of the token to ultimately allow on-chain decision making. And I'm not just saying making a vote. I'm not just saying we vote and something says yes. That again, your DOT token can literally change the behavior of the network itself. It can literally upgrade, can change the fees, can change anything you want can be changed. So unlike other systems where they have a voting token and they say, oh, this is a utility token, it's governance, right? That token, if it's just, saying yes or no in some Excel sheet or whatever, that's not actually useful, right? We're talking about actually enacting changes through ownership of the token. And then finally, beyond all of this, this is the real use cases for DOT. Then, of course, there's the market, right? How does the market actually evaluate the value of the token, the value of the block space, etc.? Well, you have trading, you have, exchanges, you have all that kind of stuff. But that is not the utility. The utility of DOT is not to be a currency. It's not to be a value of exchange. It's not to be a medium of exchange, not to be anything like that. It is meant to be a way for us to access secure block space, for us to secure that block space, and to make decisions about the future. That is the utility. Now, you have a comment. No, but I can repeat your question if you like. Just speak. So what happens when you have an identity? So this is going back to the last slide. So let's go back. Sorry, I should have then heard your question. But assuming you have an identity and then you've transferred your last one dot out, the answer is that won't happen because hopefully the identity system, the palette, will put a reference counter on your account, and the reference counter would stop you from transferring your one dot. It says you cannot transfer this dot until you clean up the data and identity. That would be the good system. The identity is one of those that consumes. Yeah, consumes. Exactly. So it is consuming, an account and it's using that stuff and then it, like, again, if it's done correctly, then it would say, hey, don't allow him to transfer his last one dot until he deletes my data from my identity. And we would also hopefully in identity have a storage deposit there as well on top of all this, which would mean that the user couldn't even transfer his last one dot because he would have it locked up in the storage deposit of the identity system. And that is actually the case. So it wouldn't work that way. Okay? So all the tools are available for you to make sure that happens. Anyway, sorry, that was going back and going forward. So going back to the utility token. Did what I say make sense? Does it give a feeling like I don't Polkadot? So cryptocurrencies in general, very speculative, very soft, use cases, etc. I do not argue that Polkadot is, better than all of the other ones in some way, but I do think that if you were to ask many people in the ecosystem, what is the true value and utility of your token, they're going to struggle. They're going to flop a little bit, right? At least I feel confident in being able to say that this is a pretty clear story about the value and utility of the DOT token, right? We are providing a resource. That resource may have some value. Again, the market will decide. And the token backs that. The only way to access that. Okay? Okay, cool. So what is the ideal usage of DOT tokens? So given these different utilities, we can actually on-chain create incentives for how we actually want the DOT token to be used. So approximately in our system, we have things programmed in such that we encourage 50% of DOT tokens to be staked, about 30% to be locked up in parachains, and the other 20% to be tradable or usable in other systems, right? And I think I'll go over these different breakdowns here. Yeah. For voting. So yeah, so voting is using a lock. So if you have staked tokens, you're also allowed to vote, right? And so again, voting is whatever kind of lock on top of it. So really, voting is like if you own the token in any of these places, you should be able to vote with that token. So parachains is not currently freeze. But staking and tradable, you'll be able to vote with those tokens as well. Yes, exactly. And so this is the other system. Like, if you use, when you're designing your palettes, if you design your palette to take a reserve, then you are blocking the user from voting with that token. So you might encourage them to actually do a lock, but you need to make sure that it makes sense that they can actually vote and lock with the same token, right? Okay. So dot inflation is currently configured to have a 10% inflation per year. Newly minted tokens are distributed to stakers and the treasury. Okay, and we'll look at the next curve here. Actually, I had a conversation with a student, and this made a lot of sense here. One of the primary purpose of using the dot token is for securing the network. We want most of the tokens to be staking. Again, the reason why it's so important is because Polkadot provides shared security. Polkadot is inherently needs to be very, very, very secure so that it can provide very, very secure behaviors to all the chains connected to it. That's like one of the major value propositions, right? So we really encourage a lot of tokens to be stuck in staking. Now, one of the narratives in the parachain ecosystem is that the dot staking, the dot inflation, 10% is quite high, and this is blocking other chains from using dot token and locking it up in other ecosystems and other places, right? Everyone wants like, hey, put dot in my parachain and get your own inflation, use it as a value locked, right? Has anyone heard of this thing? They're asking to lower the inflation. But in fact, this isn't good. The more that dot token goes into these other protocols and does all these liquid staking and other kinds of DeFi primitive stuff, then the tokens are leaving being staked on the network, leaving being securing our network. The dot token is not meant to be a basis for you to bootstrap your ecosystem. The dot token is meant to be a basis for us securing our network, right? So, I actually kind of push against that narrative a little bit, and I think that a high inflation rate actually encourages the behavior that we want to see in terms of securing our network. Comment.
Yes, as you say, like we can put some incentives on to control behavior on where do we want the token to be allocated inside the
Yes.
on chain, right? But all it's a double-edged sword because if the inflation it's a good thing in one place and people are try if you're trying to say like I want to influence these people to stake more,
Yeah.
but they see the inflation is too high and they decide to make those liquid staking, it means we have to redesign in terms of to kind of redirect now their incentives. Like it means people are not really aligned with that. That's why their behavior is changing and they're trying to put more alternatives.
Okay, so you're saying, sorry, what I'm hearing from that was that we have so much incentive on staking that now people are making liquid staking protocols?
No. There's too much inflation and
Okay.
people are making liquid staking. It means like those incentives. Okay, the token is designed whereby you have to stake to kind of combat the inflation, right, and get the rewards, right? But people are still saying inflation is too high, and that's why we're making other protocols and using DOT as a collateral to get liquid staking and everything. So it means the behavior is not really influenced enough because one factor it's kind of diverging them from actually staking because they see like just the staking the inflation is too high. Yeah.
So yeah, I hear what you're saying there. So I think what you're trying to say is that that there are other protocols trying to jump on top of this staking stuff to be able to draw them, like using liquid staking to draw them into their ecosystem. But you as a dot holder, when you put your tokens in a liquid staking protocol, you are putting extra risk on your dot tokens because now your tokens are part of some other, economy, right? So I guess you're asking how do we encourage people to stake their own dot tokens directly, right?
Exactly. Well, then because the argument is the inflation is too high. That's why we're building this
That's not
alternative.
I think you're confused. To be honest, I think I'm a little confused in your statements because you're saying things which don't to be correlate. But let's continue with the presentation, and maybe we can touch back on this after we go through everything. But
Okay.
I have a feeling that this liquid staking stuff and the inflation is too high are not the same narrative.
Okay.
Okay, so that I don't have that feeling right now. Okay. Okay. So let's go more into and how we encourage this behavior. How do we get, given some inflation, how can we encourage a certain amount of tokens to be staked? And I think, what's interesting is we want to have a staking system where we want 50% of tokens to be staked. Not more, not less, right? So we cannot force or tell users how to use their tokens. So we encourage an ideal behavior by associating the dot token usage with how inflation is distributed. There's a function that redirects some of the 10% inflation to the treasury instead of stakers, when the ideal rate is not the staking rate. Therefore, token holders are incentivized to maximize the staking system such that it will match this ideal rate. So this is the thing. If there is 40% staking and our ideal curve is 50%, there's a 10% difference, or like a 20% difference, I guess, from the ideal. This will make it so that the curve, that our inflation curve, will send more tokens to treasury and less tokens to stakers. If you go to 50, then all the tokens possible going to stakers will go to stakers. So they're making as much as they can possibly. And then if you go past 50%, then again, we are lowering the curve and sending it back to the treasury. So if you overstake the system, you are actually lowering the overall rewards everyone will get. So again, we cannot control how people exactly do things. We can only create incentives for behaviors, right? If you are a rational actor, you will, if you have a lot of dot token, remove some token from the system so that the inflation curve is better, more efficient, and now you have some liquid token, right? This is actually better for you, right? So this is kind of, we naturally let people sign. And I think if you actually look at the staking rate, it's almost exactly 50% the whole time. It just works. So this is a graph of that exact behavior. And this graph actually, it might have already changed or is planning to be changed, It's already changed. Okay, so I need to update the slide. I apologize. But basically the change that was made, okay, let's talk about the slide first, and then we'll talk about the change that was made. This slide basically shows this. This is the ideal staking rate, right? So if we get to, I guess around 50% staking, yeah, let's see. So the blue line is inflation vs staking rate, right? The green is the APY of stakers vs the staking rate. Total is inflation versus staking rate. So the bottom line is staking rate, and the top line has a different thing based on the graph here. So this is the inflation based on the staking rate. So you can see, I guess this line is a little bit past 50%. So maybe the 50% isn't exactly the right number, right? Approximately. But you can see here the ideal inflation curve. It hits the maximum inflation when the staking rate is approximately 0.5%. The APY of the stakers will obviously go down as more people stake. If only one person is staking, that guy is making a ton of money, right? But obviously it will go down up to a plateau at 50%. And then if you add more money past 50, it goes down even more, right? So there is this ideal curve where everyone's getting in, right? As an individual staker, you're getting in, you're getting the best you can get without dropping it even further, right? And then, yeah, the black is the total inflation. This black line here, you can see that inflation is always constant. So where we determine the money. So what has changed? What has changed is this. This curve shows that the inflation here, at this point, this intersection, the total inflation of Polkadot is 10%, and 100% of that is going to the stakers, right? What's happening here, when there's a discrepancy here, this discrepancy, this amount is going to the treasury. So at this point, no tokens are going to the treasury. That's not good, right? So what we did, because this was so efficient, this was like too efficient, we weren't getting enough tokens into the treasury, what we did was we lowered it so that the maximum amount that stakers get is not the full inflation, and there's always a minimum amount of inflation that goes to treasury. Does that make sense? So you imagine we just lowered this curve a little bit, and we ensured, okay, there's always going to be a small fraction that will go to treasury no matter what. And even if you're perfectly ideal, we won't take all of it to the stakers. But there's still exactly this curve, exactly the same behaviors. Right? Okay. These are all programming. So I mean, the best answer would go to the runtime and configure. I think it might be 10%. I don't know. That's a good question. Maybe we can look at the runtime. But what I would say is that, the number doesn't matter, right? Like it's just a configuration. But there's somewhere I can find the answer for you. So remind me. Okay. So that's how we can encourage some of the behaviors for staking, at least, right? Parachains actually has a similar behavior. Parachains, there is a formula inside where we're checking how much DOT is being held up in parachain leases, and that is also affecting some of the inflation curves as well. Sorry, one more. About staking, okay, before we go on. Thank you.
How is this made visible to the stakers or shareholders, token holders?
Yeah, the APY of staking in Polkadot is not fixed, right? Like you actually go some places, APY of you can stake your DOT tokens to get this much APY. That changes. So as there's more tokens, your APY will go down, and as there's less, like that kind of stuff. So you can see in real time, based on the last era, what the APY was for token staked.
But like, is there any way for the token holders to kind of like, instead of like try and just know what the figure that they need to go to?
The thing
would
is,
be?
it's very dynamic, right?
Yeah.
So, I mean, all of this is exposed through, like, if you go to Subscan, you'll see an APY number. If you go to, I'm sure many sites, they have this number. Like, even I think the Polkadot.js apps has this number calculated based
Okay.
on some information, but it's very dynamic. Like, literally, someone adding tokens that last
Yeah.
era or last other era will change that number.
Okay.
But I mean, this code is programmed into Polkadot, so you can
Yeah.
see actually where the exact formula is for this thing.
Yeah.
But the inputs are dynamic. If you go to Polkadot.js, you'll see the APY. Actually, you go to the staking dashboard. I heard it has an even more efficient calculation of this number than even Polkadot.js. So the staking dashboard is very good. Thank you, Ross. Okay, so parachains. So again, Polkadot provides many utilities, as I mentioned, but arguably the most important utility is providing flexible, secure, and scalable block space, right? Developers can purchase this block space as a fixed term or on-demand parachain only with a DOT token, and maybe there'll be many more ways to do it in the future. And if you believe that flexible and secure block space has value, then you agree that DOT token has value as well. That is just a very simple statement. I'm not claiming what the value is. I do not know what that number will be. But I would say if you believe the block space has value, then the DOT token inherently has value as well. So let's do some back of the napkin math, okay? And this is, again, a little bit, the old thought of like the, just parachains, being individual cores. But, assuming there's like 1 billion DOT, that was the initial token supply. Assuming that 30% is locked up for parachains, that's around 300 million. And assuming that 100 parachains exist, or maybe 100 cores is maybe the updated version of this slide, 100 cores or 300 cores, you might assume there's about 3 million DOT per parachain slot, right? Or 3 million DOT per parachain, for how much tokens should be distributed for that, how much it would cost to access that token. So that is at an equilibrium, right? So this is some basic economic math you can figure out to how expensive these cores or this block space should be at a high level. Right? And of course, it's hard, that's a back of the napkin math, some old ideas. A lot of the economics is changing, right? As we make the market more free and adjustable, you might see some of that math make sense for like an average curve, but the on day, on week, on month price demand of a block space might, vary a lot. And then we have tools like Elastic, which will exactly cover those scenarios, right? But I do think, this kind of thinking should be where the average kind of cost of a parachain slot should be at a high level. Okay. So, given the existence of value of the token, we are able to then actually use that value to secure the network, right? So if users want to provide security to the network, they can stake their tokens. Stakers are incentivized by doing this, by getting rewarded for good behavior, and then punished, right, slashed for bad behavior. And punishments are very aggressive. They're so aggressive that they should prevent malicious actors from doing malicious activity, right? And you can look at that, more features here in staking. But really the idea here is we have some value. We can then let users get rewarded for doing good things, punished for doing bad things, and this is exactly the kind of behavior that we expect and that we can use to encourage and provide things like security to the network. In the staking system, there are two rules. So when you had in this project, when you build a staking system, we had the validators and the delegators. But in Polkadot, we have a little bit something more advanced. We have validators, those who actually run and build new blocks, right? And then nominators, users who place their tokens behind one or more validators they think will perform the job well. Validators and their nominators are rewarded based on the work done for the network. And the rewards may vary day to day, but very consistent over time. So literally, you get these things called error points, and error points will reward you for things you've done on the network. So when you actually, back a parachain and actually do some calculation for them, you earn error points for that. If for whatever reason you were not randomly selected to, validate a parachain block, then you're not getting error points for that one error, right? So you're going to be having slightly less rewards. But then another error, you might get selected twice, right? So on average, this is a very stable system, but that's why, when you look at your rewards day to day, it's not consistent perfectly, right? That's the whole idea. And then what's another important thing here is that, again, as a nominator, you're actually selecting one or more validators that you think will do a good job. Let me see if I have a slide on it, but if not, we'll talk a little bit about how this encourages actually new validators to enter the system. Yeah, I don't. So I mentioned in a previous slide that nominated proof of stake is a less scalable solution, but is a better one for the philosophies and decisions of the network. The nominated proof of stake system basically does, and you might have heard about fragment and stuff like this, these other ideas. You have a bunch of people who are signing up, I want to do the job of building blocks. Instead of like delegation, where you just pick one, right? And you hope that that person gets in the set, and then you get rewarded for that process. That's a very simple system. It scales very well. It's exactly like, fixed complexity, etc. Instead, in Polkadot, you have the ability to choose multiple people. I'm going to choose this guy, this guy, this guy, this guy. I think they will all do a good job, right? And you have to think they all will do an all equally good job. And then our algorithm will calculate the perfect distribution of your tokens across these validators such that the stake of each validator will be as equal as possible. So it could be that 1 week your tokens are validating Shawn. The next week your tokens will be against Ankan. And that's all based on the distribution of tokens and other people making votes. So you can imagine there's a very complex problem here where we need to have all these different lines pointing to all these different validators, and we need to figure out where should we put tokens such that we optimize that all of the different validators have the same amount of stake behind them. Now, we solved this problem with fragment. This was, I guess, a paper written in the 1800s. A researcher was finding a similar problem, and he was able to solve this problem using a n log n complexity solution, which is what we use, and it's pretty efficient. But going from that, I want to talk about the behaviors that this encourages. One, this provides two main things for Polkadot. The first one being that our algorithm tries to make sure that every single user has even stake. What this means is that no individual validator has a disproportionate power onto the network. So other delegated proof of stake systems, like I think in Cosmos, the more tokens you have, the more times you're selected to produce a block. So if you have like 60, 80% tokens, you're going to be making 80% of the blocks of that network. And I think Ethereum is actually the same way. If you have a bunch of tokens, you will actually split up and create a bunch of validators, like your 32 ETH. If you have, 1 million ETH, you'll make, 30,000 validators, something like that, right? And then you'll be selected on average 30,000 times more than someone who has one validator to build blocks. This is an unequal representation of this guy being able to attack your network because he has so many more chances to build blocks and do attacks onto your network. In our system, where we even out all the validators to have the same amount of stake, every single validator has like a equal opportunity cost or attack cost onto the network. And this is one of the ways we're able to achieve a much higher Nakamoto coefficient over others given the same number of validators. And I'll talk about that more in the future. One last thing. The other thing it encourages that nominators not to just put their stake behind the big whales who will be guaranteed to the set, but to also vote and find small validators who are high quality but haven't been put in the set yet. Why? In a delegated proof of stake system, that's like the Cosmos system, you pretty much are encouraged to basically put your money behind the number one guy. Because number one guy will be in the set every single time, you're guaranteed to get your rewards. If you put your money behind a small guy and he loses his spot in the set, then there'll be a whole month or a whole day or whatever, you won't get any rewards. This is very bad for you as a holder, right? You can only delegate to one person. In the nominate system, you can have 16 votes. This is in Polkadot, you have 16 votes. You can say 10 of them will be people who are, kind of guaranteed to get in the set. And the other 6 will be people who are more speculative, new voters. But if I get in with one of the new voters, I will be proportionally a much larger part of that stake, right? And I will get a much higher proportion of rewards. So given that all validators have an even stake here, they all get evenly rewarded. If you are a big chunk of one validator who got in his set, you will get a much bigger reward than if you were inside of the validator with a bigger set and you're a smaller token. Does that make sense? Yeah, but you're balancing risk, exactly. So you have more risk putting against behind this guy, but you think he's high quality, and when he gets in the set, you're going to get rewarded for that. But again, the whole point is with the nomination, You don't have to risk your tokens that you won't get any reward at all. You put some tokens behind big guys, you put some tokens behind small guys, and if enough people put tokens behind small guys, the algorithm will figure it out and actually put a small guy into the set. And now you've gotten big rewards. So this system actually encourages the discovery of new people. In a delegated proof of stake system, which is what most proof of stake systems are, you just get incumbents and whales who stick around and chill, and the quality of their performance goes down. The impact on their network goes up. Like they have an uneven control of the network. Non-proof of stake system allows for a more dynamic cycling of validators who are high quality, giving an opportunity for stakers to actually go and find things. So staking isn't, by the way, going back to liquid staking and staking on an exchange, staking isn't, I have some DOT, I press a button, and I get rewarded. Staking is not some kind of free inflation. We provide inflation to stakers because your job as a staker is to find good validators, right? We want you to be able to go out and find it. And if you can find good ones and you can do your job well, you will make more money than others. So going to an exchange and just pressing a button to get some reward, and them cutting also a bunch of the reward off of you, is doing terrible things for the network. It is literally just not great. And you will get punished. When these guys start getting lazy and then start, underperforming, or they have an outage, your tokens will get slashed up proportionally, and the people who will survive were those who actually looked and researched and found good stakers. This is that system. Again, we cannot control behavior. We cannot control that this will happen. We can only incentivize it, right? So it's going to be a little bit of time until someone gets super slashed out there that they start realizing, wow, I need to actually think about and manage and update my nominations, okay? Let's take a pause on this. Any questions about this? Okay, yeah, can we bring a cube over here?
I had a question about that. So, like within Polkadot specifically, like for parachains, for the few parachains that I'm familiar with, they mostly have like delegated proof of stake systems. Is there a technical reason why they don't do nominated proof of stake, or are there parachains that
So
do?
many things. NPOS won't scale well on parachains. Again, it's a very complex problem. It's already having trouble scaling on the region chain. But truthfully, I think most parachains, if I had to be honest, their staking system is bullshit. They don't provide rewards. I mean, like they're not providing security. They're not providing anything. Like it could be that a parachain, again, if their token, so the steps, does their token have true utility? If it has true utility, then it has true value. If it has true value, then we can use that token to incentivize behavior. Now, staking could be a way to incentivize some behavior. It could be, for example, I'm not making any specific comments, but like A-Star has this idea of this DApp staking, where basically instead of finding good validators, you find good dApps, right? And so users can go find good dApps, see that DApp activity increases, maybe it highlights a DApp to be used, and then they get rewarded for that, right? Is that a useful system? Maybe. That sounds kind of more reasonable than I just make token for nothing, right? Other parachains, they might actually encourage staking or rewards based on liquidity providing. So I'm a DeFi exchange. To make my service useful, I need to have liquidity. If you provide liquidity to me, you'll get some rewards. That also generally makes sense to me, right? But there are other chains where it's like, okay, you put your money in this thing. We have a pallet which just gives you plus 5%. That's like Ponzonomics. It's bullshit. So start with the idea of is there utility? Are they harnessing the utility to actually generate value? Then staking can make sense. But deposit again with Polkadot, we really need to do an NPOS system because the whole basis of Polkadot is to provide security. It's the major thing. All this behavior is super important. For a parachain system, DPoS is more scalable, and usually these kinds of mechanics are not as heavily emphasized in their world.
Thanks.
Okay. Any other questions about staking? Yo, the corner, you have a mic?
So in the nominated, so still the validator that's going to be chosen to create the block, that if they have more staked, they have like more weight to create the block as well.
So I'll be more specific with economics. So the algorithm tries as best as possible to give everyone the same stake, but it can't always do that. There will be people with more stake and people with less stake, okay? But the rewards to all validators is equal. So even if you have a ton more stake than everyone else, you will get the same rewards as someone with a small stake, right? This also encourages other behavior. If you're a really big validator, you're encouraged to maybe split up your thing into multiple other validators. Like you don't want to be a validator with a ton of dots in it, because also you won't be getting as much reward because all of your money will be leaking to all these nominators, right? So everyone gets exactly the same reward. You're encouraged then to balance your stake, to find people who are small and put your tokens there because you'll get more rewarded there. So you will, in general, get less rewards if you pick the biggest guy.
When you say everyone gets the same reward, only the block creator is getting the reward as at this specific. Only one is getting, right? Not all of them getting when a block is created.
It's a little bit more complicated. Again, you have to go back to the error points. So you can think of, at a high level, you can think of, and this is not exactly perfect, you can think of some fraction of validators is equal to cores. So let's say 1 to 1. If there's 100 validators, they are exactly 100 cores. Now they're all doing work in parallel. It's not like, now one of them is creating the Polkadot block, and they will get some reward for that. But all of them are doing things like parachain validation, etc., and they're earning points for that process too. So it's not like every single block one person gets rewarded. Every single block, everyone has the opportunity to get some rewards based off the work they do. They're accumulating error points, and then at the end, they get paid out based on the error points. But the idea is that every single one of these validators has pretty much equal opportunity to get these points, and that everyone is getting paid the same, basically.
Thanks.
That's the high level idea. Again, it's a little bit oversimplification, but it's a high level idea.
So my question is on the. So as the court time will be coming, and people will be paying to get the cores, and the idea was to ban the dots like in the discussion. But one thing is, can it be like my question? Can it be in a way that the tokens which are used to buy the cores be used to actually pay the validators, as because they're actually paying for the security, right?
Okay.
And the inflation won't go to the validators, and the small part of inflation, just part of it, go to the treasury, like because directly you're paying the cause, so indirectly you're paying the validators.
I don't think I can come up with an answer on the spot. What you're saying doesn't sound unreasonable, but I think that really you need to you need people who are very good at economics to decide what behaviors does this encourage, right? But I think that what about palette development is that all of these rules could be programmed however you like, right? So it's possible things could change. It's all about behaviors. I don't think what you're saying sounds unreasonable. It sounds like there's some idea of economics in there, but I don't know if that will work exactly perfect, So it's possible. I don't know. Okay. I do think though that, again, Polkadot is set up to be an evolving, agile system. We can quickly iterate on these economic designs, just like we're being able to provide things like Elastic and core time sales and auctions. Like that's all part of the design that we don't know the answer perfectly today. We'll figure out later. Okay, let's move on. Okay, so we're talking about staking. Now let's go to governance, right? So the future of Polkadot really is decided by token holders. Polkadot has an on-chain governance system called OpenGov, which can be used to spend treasury funds, upgrade the network, manage the fellowship, support parachain teams, etc., right? In Polkadot, we utilize an idea called voluntary locking or conviction voting. Conviction voting allows you to basically increase your voting power by locking up your tokens for longer periods of time. Okay? So this was a system which we try to, as best as we can, balance out whales from people who have less tokens. Now, inside of the project that we gave, the voting system, you saw one system that could work if you have identity and symbol resistance is a quadratic voting system. But given that we don't have that, we came up with this idea called conviction voting. So the idea is that if you have such a conviction, such a belief that some idea is important, you can choose to lock your tokens for longer and longer periods of time, and then we will give you more and more vote power. And the idea is this: if your tokens are locked for 224 days, or some not like 1 year, 2 years, whatever you can amount, then it is more likely that your belief or your research and investigation or alignment with the blockchain is better, right? That if you're just some big whale, you're saying, I'm just gonna fuck around, just put some money here, whatever, then sell it. You may not actually have the right incentives behind. You might actually be trying to manipulate the network. But if you actually truly believe, I want DOT to succeed, I don't even care about selling my DOT for 2+ years, whatever, you can lock up your tokens and then get more conviction for you on that, right? And so this is a tool that has been used a lot. And actually, I mean, this is a big topic of conversation around Polkadot right now, because we have whales in Polkadot with more dot than I can imagine how they even got it. And they're locking things up for like 5 years. They already did conviction voting for like 5x or whatever, like the maximum thing. So they're already locking in millions and millions of dollars for a 5-year pipeline of the system. And they might have good ideas or bad ideas, but they are definitely putting their money where their mouth is, right? They are definitely encouraged over the long run for dot price to go up. So this is the kind of systems you can create without, having identity. 2 questions. Let's get to Mike's. Yeah.
But that seems like it's giving like more power for whales, right?
It's giving more power to whales who have alignment with the long-term vision of dot. So I want to clarify this. The goal of these systems is not to ensure perfect democracy. It's not to ensure fairness. There's no fair in this thing. I'm not going to make a system which is trying to give the same amount of dot to every single person. The purpose of the system is to survive and succeed. 100%, for example, if you have an architect like Gavin Wood, right? If he has it's not wrong that he has a disproportionate amount of influence on the network, because he knows so much more about blockchain. Some random, Mark Cuban guy who's like buying, apes and NFT whales, whatever, like this kind of thing. Even though he has a lot of money, he shouldn't necessarily be able to, I don't know how to say it. Like it's not that how do I say this? Or that's the best example. Like a random person on the street who bought DOT because they saw it on some exchange shouldn't have an equal vote on the outcome of the network. They don't have the insight and knowledge about the technicality of the system, right?
Yeah.
So the goal here is that you are a whale. Maybe you do get more say in the system. You definitely get more say in the system if you lock it up for longer, but you are then locked into the incentive of making DOT succeed.
So basically, like, without the conviction multiplier, like without the time factor.
Yes.
Like, if you have more tokens, you have more power. However, with the addition of the time multiplier, then that adds another dimension.
Yes, exactly.
So like there is
Dimension
still
alignment.
a bias for like token
Big
holders
whales?
of more tokens.
Exactly.
However, it's balanced a bit by conviction.
Yes,
as
by
well.
alignment with the long-term success of the
Yeah.
network.
Okay.
Exactly. And again, I don't think this is perfect. I think that I'm waiting for identity reputation systems to make even better systems for other kinds of things. But this works pretty good for what we can have right now. And imperfect primitives will allow us to make better systems.
But that can then also be tweaked to like lower the.
Oh, 100%. It already has been tweaked. It already multiple times have changed how much conviction, how much time you lock, all that kind of stuff.
Yeah.
Want to sit at the back, please? Let's do the back first, and then we can go back up front.
I have 2 questions. One is this independent on the output or the outcome of the proposal, right?
Yes. If you do conviction voting and you lose, your tokens are not locked.
Are not locked.
Not locked. You in this system, when you conviction vote, you're only required to get this lock on your account when you succeed.
Oh, I didn't
Right?
know
That makes sense, right? Imagine there's a very controversial proposal where it could be 50-50 that either is right. All the people conviction vote yes, all the people conviction vote no. If yes succeeds, then no people are on the hook. Obviously, they didn't agree with that network. They are immediately unlocked and they can sell their token if they want. They can leave.
Get it. Another is Mike, like, what is your opinion about it? I saw some like discussions of people talking about like there is some shitty proposals about marketing going on, and there is a lot of whales voting with lock periods very high. That this could potentially create a kind of governance vulnerability because everyone is locking their tokens to go to vote against these proposals, and then they will not be able to vote against other worse proposals.
So this is one of the things. Actually, this is one of the mistakes I saw in a lot of voting systems. When you and voting in one proposal doesn't take away your tokens from voting in another proposal. It's
But
all
if they're
locks.
locked.
No, but if they're locked, you can still use your locked tokens to vote on all the proposals. So if I have 1,000 tokens, I'm not choosing vote 100 here, 100 here, 100 here. I can put 1,000 on each vote. And I think I talked to some students about this. It's not about like stacking it. We use locks so that I have 1,000 vote in the system. Every single proposal I can vote 1,000 times. And if I'm
Even if in the first one you lock for 5 years, in the second you can lock for like 3 years. This will sum in turns to 8 years.
no, this will sum to total of 5 years.
So the maximum
It's all
period.
stacking.
Okay.
The
But
maximum lock of all locks is what you can vote on. So if you already voted 5 years lock, you're probably going to vote 5 years lock moving forward, right?
Yeah.
But over years, if you keep voting 5 years lock, you're going to be locked 5 years forever. So maybe 1 year from now, you start lowering it to 4-year lock, then you start lowering to 3-year lock,
Lowering from yeah. Got
or
it.
whatever you want, right?
Mhm.
But this is a big thing. A mistake that people made in the voting system was that they did not consider the fact that you're not using the token and spending it to vote. Your token is a representation of your position in the system, and you can use that position every single time to vote. Like if you're the president of the US, your opinion has an influence in the world. You can keep having more opinions. You can still have the same amount of influence in the world, right? This is an influence system, okay? So anyway, so what actually happens is when we lock up a bunch of you, so this was the hypothesis of Giotto. Me and him had a conversation on Twitter. His hypothesis is this: if we can trick or whatever, convince people to lock up their tokens for a long time, then we just encourage by nature more activity on Polkadot. Because if everyone here was locked for 5 years, then you're just encouraged because your money's locked in there to interact with the network more. If you are just immediately liquid, you don't care what happens day to day. You don't care. You're not going to look at proposals. So his idea was, how can we create systems where we just encourage users to lock more tokens? Okay. Anyway, let's keep going. So we talked about voting systems. Now we talk about the tracks. So in the OpenGov system, when you do voting, you vote on different tracks, and these tracks require different amounts of power to pass, and they have different abilities. So there is a root track. We talked about the root origin. This can do anything. In order to present a proposal with a root track origin, in order for it to actually be enacted, you need to put down 100,000 dot deposit. That's how powerful this thing is. This is a don't fuck around, origin. If you really want something at this level to happen,
Who proposed, right?
yeah, whoever proposed, no, someone can propose it. Anyone can put the deposit. Anyone who agrees with this system can put the deposit that I want this action to happen. The decision deposit says, how do I say this? You can make a proposal, and the decision deposit comes later. The proposal will just get people to just vote. What is it going on? Do people think it's good or bad? Without the decision deposit, the vote will never actually enact. It is just a vote on nothing. When you put your money where your mouth is, that's when we actually say this is a real proposal. This will actually determine something. And this decision deposit is where you can actually slash users from their balance. So if I make a proposal, hey, I want to, I want to break the Polkadot blockchain, right? Someone can do that for fun. They're going to get charged some fees for that, whatever. And maybe they can get a small slash for an initial proposal deposit. But if someone then puts in 100,000 dot, says, yeah, for real, let's try to do it, then the ecosystem can go and slash them 100,000 dot if they want to say it's bad, right? But until this deposit comes in, it's just kind of like we're just talking, We're just accumulating ideas.
So it's like a protection for execution of that.
Exactly. It's a stake required to prove that the execution of this is real, That if you really want to run something on root, that it better be good, or if you're trying to be malicious, you risk losing your deposit, right? So you can see that the deposit goes down as the cost to the ecosystem goes down, right? Let me just go through the rest of this and then we talk about it, okay? So you can see here, there's different other criteria, and I'll have next on a slide a graph of these curves, okay? But you can see here the preparation time, right? So this is the time I think required before you can even put a decision deposit. So it's at least 2 hours you have to wait before you can actually make a decision on the product. And then there's a period, the default period for the worst case scenario where everyone is very indecisive. It could take up to 28 days to happen. A confirmation period, so after the vote has succeeded, a time delay for us to actually go and execute the item, and a minimum inactivity period. So if the vote passes, how quickly could we minimally take to actually enact some change, right? These are some of the curves. I'll show you the curves. These are ideas, but imagine you can just adjust all the parameters, like they're voting, how long do we want it to vote, how long do we take to actually execute it, what is the minimum, maximum, and there are other systems in place which can adjust these systems. Like, as I mentioned here, the fellowship has control over helping enact things faster, right? So that's just some ideas. Okay, now let's quickly take a question if you had one. Yeah, you in the front first, please. Thank you.
Yeah, does the decision deposit has to be done by one person, or can people chime in to get to
I
that?
think it's one person right now, but you could imagine building a system where like multiple people
Yeah.
put the pools together. But right now it's one right now because it's simple. It's simpler to program, you know.
Okay.
Yeah, I think if like in the yeah, it's more simple to program. But you can imagine if making a multi-sig, and the multi-sig everyone pools their money, stuff like that, right? Okay. Another comment here, and then one more over there. Yeah.
At what points does the slashing happen, and like what's the
Okay. So
So,
there's a specific vote which is called like if you looked at the treasury palette, there's like reject, and then there's like reject with slash. There's like two levels. So you can say, someone can say like, I have an idea, and you can be like, no, that's a bad idea.
yeah, that's what I meant. Like,
But that's fine. They're not going to lose their money. But there's another system which you can explicitly vote on. This guy is being malicious, and then dot holders decide if they agree, and then they'll get slashed.
yeah, so I guess my question was like, if slashing always happens, then like people
Not
will just
always.
won't propose. I
No,
guess,
no,
yeah.
no. That's the thing. We don't want to discourage
Yeah.
people thinking things. For example, there's some of these marketing things. None of them have been slashed so far. But if one of the marketing things says like, hey, we're gonna take out $10 million from treasury and then just give it to one person, then that's gonna be a
And
slashable event.
what's the disincentive for people to like slash, like because you can like not slash, just reject.
Yeah.
You can slash, and that would not impact you negatively.
Yeah, well, so slashing is not an easy thing to get through. It also has a pretty high curve, so it needs to be a lot of people who agree on it. And if you start slashing people aggressively, you make your ecosystem like not friendly. Like no one's gonna propose anything, right?
Okay, so, it's like
It's
in
a
the game
human.
theory kind of
Exactly.
way. It's
We
not like a
cannot
straight
control
economic.
behavior. We can only incentivize it.
Yeah, but it's like a second degree of separation kind of incentive, because it's not like
Exactly.
you get financially immediately punished for
Exactly.
slashing.
What's so powerful? I'll get to your question, but one of the most powerful things about all of this crypto stuff is you can capture all of these feelings about a network in a single price. Isn't that kind of crazy? Like imagine there's all these dimensions of blockchains. There's like the developer community, the on-chain community, the marketing community, the vision, the thing like that. All of it somehow through the power of an open market, a free market, can be turned into a single US dollar value. Again, I'm not saying that's efficient or good or whatever, but all the things you're describing, all this meta protocol, if the vibes aren't good on the network, price goes down.
I mean, I'd agree with that, but like it's not so clear in the case of the slashing, like because
But slashing is bad vibes, right?
it's bad vibes. But how do you measure that? Like,
You don't. You measure it. You as a token holder be like, wow, there's some bad vibes from here. I'm gonna lower my position, and that lowers the token price.
yeah.
It's all soft. We taught in this class how you can program hardcore cryptographic things, but at the end of the day, it's all vibes, man. It's like it's all
I think I would disagree. I think some things are hard. It's like you do this, you're slashed. It's hard, right? Like it's a immediate.
that code. The
It's
code
a very
existing
clear
is hard.
formula.
The usage of the code is different, right? There always can be again. There's a button that says blow up Polkadot.
Yeah.
If anyone presses that button, then they all lose their money. So even though the button exists, that could be a cool experiment, right? You give a bunch of money to everyone, you make a button that says blow up everyone, right? And no one can trade their tokens, whatever. Like, no one will press the button, hopefully, even though it could exist. Anyway,
Hopefully.
let's move on. Okay. Question.
It was these two questions.
This conversation.
Yeah.
Okay. Anyway, yeah. Question here now. Can we get that mic? Or okay, you can talk. Yeah. You can propose literally anything. Yes. Yeah, conviction voting. He changes governance to make him pseudo. Why not? He makes himself pseudo. Will the dot price go up or down? Okay, then will that whale want to do that? Huh? He could change governance, of course. I mean, Bill Gates could buy every single dot token, vote himself as pseudo, and then kill the chain. But guess what's going to do? He's going to be burning his own money. Like that dot token in that whole process, right, is gonna, people will see it on chain. It takes time to enact. You sell your tokens, and now he owns nothing. Like the economy here is that you want to do actions which make the value of the dot token higher, and again, you're locking yourself up for that. Like you're not incentivized for dot token to get higher, for 7 days. Like I can make a blog post which will make the dot price go up tomorrow, right? Some kind of bullshit statement. But in 2 years, that will be, like a scam, right? So we are encouraging incentive of this dot token going up over long, long periods of time. Rational actors. Exactly.
So that there are some irrational players.
Right. And this I think I talked about this also in some of the other after class sessions. You cannot build systems for irrational actors because they're irrational, right? It's just so what you can do is realize this. Let's say an irrational actor goes to Polkadot, buys the network, pseudos it, kills it. How long would it take, you think, for us in this room to launch a new Polkadot with the same genesis, with the, before he took over the network, and then just move forward?
Oh, okay.
Be very fast.
That
So
makes sense.
the ratio of his cost to attack versus how long it would take for us to like socially fix the problem, it's very free. This is why governments don't attack this. Like governments could attack blockchains today, but if they took down Bitcoin, it would take 1 day before Bitcoin 2.0 came out with the exact same tokens as everyone had and move on forward. And the government lost all their money doing the attack. Same with Polkadot. So hey, by the way, this is a great conversation. This is what I talk about: ecosystem and economy. These are the ideas beyond writing code for the chain. So yeah, these attacks that, again, we cannot forget the human aspects. One more question here.
So first, to just rebut your point, I don't think, and like, so if we just see 50% of the tokens are staked and 30% are locked in parachains, so like even if you're giga rich, you can only buy like 20% of the supply until someone actually like unstakes, right?
So
Like
yes, so you would not need necessarily 50% of tokens to be able to make a proposal pass, if assuming that it's all dependent then how many people are actually going out and voting, right? Is that what you're saying? So they're basically like
No, like you're saying, if I'm Bill Gates, I have all the money in the world, I can just destroy DOT because I can buy all the DOT, but
Okay.
you can't because like half of it is staked and half of it, or 30% of it is like.
yeah, but he could buy validators, or he could he could do like some kind of other
Okay.
system. But you're right. I mean, the other attack is if I'm gonna buy all of DOT, you know how much the price will increase. Like the way that these markets work is that every time you buy DOT, you're moving the slider for the sale price, and so your first of 1 billion DOT that you buy is gonna cost whatever $10 that is today. Your 100,000th of a billion DOT you're gonna buy is gonna cost $100, and it's gonna go exponential. So it's a very hard attack. Yeah.
Yes, and then like the second question. So is there anything on the roadmap to improve the liquidity of DOT? Because for like, if only 20% of the supply is liquid, like if I'm like a guy with a lot of money, like I don't know if I want to buy because like it's just not liquid enough for me, right?
Well, I mean, I think that's the thing. You're coming from the perspective of an investor, right? What I'm trying to argue is this: is that I think that is something the market has to decide. It's different. That we have to start with. There's a value for block space. An investor will realize that that currently the token price either is below, matching, or above the block space value. And as an investor, you will purchase DOT based on the arbitrage between what you understand to be the value of block space and what the token price to be, right? I don't think liquidity
yes, but like okay, at the end of the day, if you're investing in something, the plan is to eventually like sell, right? If the exit door is very small, then like, I mean, I guess the idea is like you shouldn't. We're not incentivizing people to exit.
So I guess maybe the question is: so you think you would prefer that like 40% is liquid, 20% is
Not necessarily like you could have
Parachain.
like a derivative, like so like there's DOT perps, right? But they're like super illiquid. Like maybe like you can get a derivative of DOT that's like liquid, so like people can.
usually these derivatives compromise the security of the network because you end up basically reusing tokens which are for staking, and there are other ways that stake tokens now can like get slashed or whatever, like be manipulated, and then it just becomes like a house of cards. So you need to tread the waters carefully. I truthfully think that we are trying to actually keep DOT from having these restaking or reliquid or whatever derivative products because its purpose is to be staked directly. It's like it's very clear what we can control in our system. I don't know. I don't know. Again, I don't think you will ever see a decision in DOT being made for improving the investor perspective. We don't give a fuck about investors. We give a fuck about building a high quality product, which is providing good utility to the world, aligned with our philosophies, and ideally investors are aligned with that thing. I think that's really the
Yeah, like I get that, but it's like for like Polkadot to really take off, you need a lot of money to come in my opinion. Like you need to win.
so at what cost? At what cost do you compromise whatever? Like do you not
Like,
think
there's a scenario where like we build all this great technology, but like there's not enough people using it, and then we just like get outcompeted by other chains, and like that's it, right? It's just like a very small community then.
I feel like we're having a very theoretical conversation.
Yeah, yeah.
I could also just say that people will build on it. Like I think that there are a lot of products, like again, excluding DeFi, which I don't think is the best product for Polkadot, like identity systems which have zero people working in Web3 on this, voting systems, reputation systems, etc., which Dot is a great use for. Like I think gaming as well. Like all these things require flexible, cheap block space. I mean, these are untapped markets. I'm like you're worried that we haven't captured the existing market. Again, going back to Peter Thiel, going back to 0 to 1, you want to be targeting untapped markets. It's much more exciting to be a monopoly owner of an untapped market than to be a small stakeholder in an already, overtaken market. So I recommend you try reading 0 to 1, get some vibes from that, and feel. But again, it's all opinions. If you believe that, make your chain with your economics.
Yeah.
I don't know. Again, it all goes back to the philosophies of Polkadot, right? I think that's where it comes from.
Just something I missed. Like people who lock their dot, can they stake them as well, or they're
Yes,
locked?
yes. So staking and voting are the same. You can lock the same tokens.
So, one question. I don't have this clear. What happened in case of opposite proposals that maybe are both accepted? Maybe, I don't know. You say that, for example, the limit for the inflation is 10%, but it's configured. So I understand that this may be configured somehow by voting or not. Or
Nothing with voting. The inflation only goes to treasury and stakers.
okay,
Voting is not involved. But if you
Okay.
are a staker, you vote. Usually you're staking, you're voting because it's the same tokens.
okay. I thought that maybe this parameter was also configurable.
No, but the voting can affect how treasury spends money, and
Okay.
treasury is part of where inflation goes.
But in any case, it doesn't matter. So what happens if one proposal it's maybe very important and someone look at this and says, hey, I don't like this proposal. A lot of people has been spending a lot of money saying hi or no. And then I wait only one day, half day, I don't know, and then make another proposal to deny the previous proposal. Is this possible, or how much time does it take to this enactment period? After this time, how much time must be waited?
I think once the proposal passes, I think there maybe are some backdoors to be able to with the root track to stop something from enacting that already passed the proposal. But usually the main way is if someone proposes something, the only way to stop it is to vote no on that thing. But there are probably some again, it's all programming. I mean, you're asking me the kind of implementation details. The enactment period. You imagine there's a queue in the storage. You can make a root call to delete that thing from the queue, right? But it takes a lot of effort to do that. And generally when something passes, it passes. That's the idea is that it passed, right?
Okay.
Okay, let's move on. Let's move on. I don't know if I would say read the code. Like if you want to know exactly the details, that's the kind of thing.
Okay. Just
Right?
asking. Okay.
Okay, so maybe I can answer. All right. So I want to show you these numbers and how they show up on a graph. So each track has their own set of curves which determine if the proposal has passed or failed. All votes will eventually resolve one way or another. There is no undecided vote. It will either always pass or always fail, depending on these curves. You can find these curves on the Polkadot.js developer console for each track. So here you see there's a root call that's outstanding. You can see someone proposed this root call. It is deciding, so someone put 0.033 KSM to make the proposal. The same person put 3,333 KSM to make the proposal be decided, like it's actually going to happen. So there's a lot more tokens to do it. You see it's deciding in 7 days, whatever, and currently the outcome is 99% I, right? This is all this stuff. So all this is in Polkadot.js, you can see with every existing proposal. And if you drop it down, you can see the curve. So this green line is the actual vote system right now. But you can see here, if you want something to pass very quickly, it is required that you have mostly entirely approval and that you have mostly entirely support. So this is saying, of the tokens who have voted, how many of them agree, and how many tokens in the whole system have voted. So if we want a proposal to pass in 1 second, what do we need? We need 100% of people to say yes, and 50% of tokens to vote yes, of all tokens in the whole system, right? Does that make sense? This is literally the proof that 50% of tokens can make anything happen. But obviously, 50% of tokens don't always come out to vote. In fact, the amount of people actually voting is much lower than that. So over time, we decrease the requirement. We continue to lower it all the way down to basically, to 0 in this case. Other ones, we require at least a minimum, and like 5% of tokens have to vote, right? But we can keep lowering it such that even though not everyone voted, we take, how many people have voted, and we check if that matches that criteria, and we also check if it matches this approval criteria. So it could be that this root proposal, this could brick the whole blockchain. It could be, according to these graphs. Let me see. Is this 5%? Yeah, it could be according to these graphs. As I understand, one person votes yes, brick the chain, and eventually it'll pass. Because that one person is 1% of the whole network, whatever, or some small percent, and this curve will go down, and then they'll see 100% yes, and then it'll pass, right? But obviously, if that's the case and you don't agree with it, you vote no, right? And that increases. So as you're increasing the supports, you're basically being able to make a decision better and faster. Does that kind of make sense? These two curves, we are, over time, we need less and less people to vote, but it gives more time for people to vote if they want. And then over time, we need less and less support for things to happen quickly, right? But we can imagine how this supports hard decisions in a long time and easy decisions in a short time. Those are the curves. Okay, so I think I get this example already. So the origin with the highest level of privilege is the root. Extremely high levels of approval or support are required early for passing. And the enactment period is also very large. So for instance, a referendum proposed in this track needs to amass 48.2% support, the total network issuance, by the end of the first day with over 93% approval to be considered part of the confirmed period. So for something to pass in 1 day, you need 48% of all tokens in the entire system to vote and 93% of them say yes. So DOT tokens are locked when you vote on a proposal. You can reuse your locked tokens across multiple proposals. Voting on one proposal does not affect your ability to vote on another proposal, right? You can also reuse your staked tokens, which are just locked, to also vote. That's all the things we just talked about here, right? You can update your vote while proposal is ongoing. This is another thing that I hope that all the people who built voting did, right? That when I vote yes, doesn't mean I'm locked into yes. I should be able to update and say vote no, or lower my vote, or increase my vote. I should be able to update it as much as I want. As long as the proposal is going on, I should be able to update my vote as much as I want. If you use conviction voting, your tokens might be locked for a long period of time if it passed at the end of the proposal, right? So if you do conviction voting and a thing passes, you will be locked in for that conviction time, right? And there's no way around that. Yes. Can we get a mic?
Also, the proposal can also be updated, right?
The proposal generally cannot be updated that much. No. So if I propose I want to increase the staking rewards to 15%, that proposal is locked in. You vote no if you want to change it. You vote no, and then you make a new proposal.
So is that a front-end feature? Because on the OpenGov you can see first update, second update that these guys put on proposals.
You should have the text.
Yeah.
Like words. Yeah. That is all off-chain.
Okay, because the execution, the hash that will be the blob that will be executed cannot be updated, but the story around this can be updated.
Yeah,
Is
so
that
the information, the text about intention is an off-chain thing. The blockchain doesn't care why you made a proposal. The proposal is more specifically, I want to call mint token
Get
to
it,
Shawn. That is the thing that's on chain. That can't be changed. That's like the hash of the proposal is the call.
No, I
The
get it.
text on why you want to mint to Shawn, that's a story. Like, that's not relevant for the blockchain. The blockchain shouldn't hold this information. All right, treasury. We have the on-chain treasury, which is used to support the network. It is funded through inefficiencies of the network, and also 80% of all transaction fees go to the treasury. So again, in systems like Bitcoin, as I understand, all transaction fees go to the miner, to the person who made the block. In Polkadot, we already have a pretty good inflation. Validators are already getting pretty good rewards. 80% of the transaction fees actually go to the treasury. But all this is configurable, right? Another thing, there's a sell pressure, or not a sell pressure, a use pressure. The treasury will automatically burn 1% of its funds every spending period. So I believe the spending period on the treasury right now is like 28 days. So every 28 days, it will go and spend its money. And after it's spent its money, whatever is left over, 1% is burnt. So there's an encouragement to actually spend money, not to just hoard the money forever, but to actually spend it. Otherwise, it'll just get burnt, right? It's getting wasted. Yeah, okay, bring the mic to you.
The way for the treasury to spend money is like the
Governance.
Yeah. Okay. Cool.
Yep. All right, outlets. So as we mentioned already, the treasury has different outlets for spending. There's proposals, there's bounties, there's tips. Usually these are kind of like different levels of how much you want to spend. Like a tip is a very small payment, very easy to give. If you do a PR on Polkadot, you can get a tip. Like you can, if you change one of the palettes to fungibles trait, you can get a tip, But proposals are usually like, like bigger spends. I want to have like a 1-year timeline and build this cool thing, etc. Polkadot Treasury probably has more or less than this number, but it's like a lot of DOT. It has a lot of money. So when you're talking about you have ideas you want to build, like there's a lot of money waiting for you to spend it. Okay, so that's all of the economy. Let's jump into ecosystem. Okay, let's keep going forward. I'm worried about time. So ecosystem. So obviously we've been showing you Substrate, which is the primary client for Polkadot, but there are other ones. An important part of an ecosystem is to provide multiple alternative clients for the Polkadot node. So we have one in C++ and one in Go being developed by Soramitsu and ChainSafe, respectively. This can help provide some resilience to the network against software bugs. Now, I want to mention, this is one of the things actually is a big topic of conversation right now with Ethereum, that Ethereum has multiple clients, but like 80% of the nodes all use Go Ethereum, right? It's not great. And actually, Parity, one of its historical moments in the history of Ethereum was that there was this thing called the Shanghai attack, where there was an exploit in the gas system of the Ethereum nodes, and basically there was a gas that was cheaper than the work required, so you could actually DOS an Ethereum chain by calling this function over and over. That all of the other nodes of Ethereum crashed because of this, except for Parity Ethereum, because Parity Ethereum was so efficient that it could actually handle this overhead. And so thanks to Parity Ethereum, the network didn't die, it didn't halt. They were able to fix it, patch it, and launch it. But that was what, the fact that we had multiple clients and that Parity's client was so performant was the reason why Ethereum didn't halt that day, right? That being said, there is a disadvantage of Polkadot. You can make multiple clients, which will prevent against some kinds of bugs, but the WASM is unique. There is one WASM for the whole chain. So if there's a bug in the WASM, then no matter how many clients you have, you still have a bug in the whole network, right? So this is why the WASM in the runtime, you as runtime developers, it's extremely important that everything you build is smart, efficient, bug-free, no panics, no overflows. There might be times where I reviewed your code and I said, hey, this could be safe. And it's like, oh, but it can't really happen or whatever. Like, it doesn't even matter, man. Just it's free to just put the thing in there. Like, this is the single point of failure in terms of the Polkadot ecosystem. That runtime could be the single point of failure. But there are other client things like, networking bugs or database bugs or whatever that the client implementations will help solve. Types of parachains. Again, this is something that is evolving over time, but I want to talk about the current state of the world. We have system parachains, which are basically extensions of Polkadot, and we have market bot parachains. These are like all the businesses and parachains that you're kind of familiar with, right? And again, this list will probably grow. All the different types of parachains might grow as the allocation systems are implemented. So actually, even in the forum recently, I had mentioned the idea of a disposable parachain, a parachain state that will just get thrown away when we don't need it anymore. And there might be uses for that. So there might be many, many types of parachains. But the basic ones we know are the teams out there, the parachain teams, and then Polkadot trying to extend and scale itself into multiple parachains. Oh, what did I do? Resume. Okay, so system chains, these are parachains that contain core Polkadot protocol features. So Polkadot uses its own parallel execution to scale itself, right? So you can imagine right now on the relay chain, there's staking, there's balance transfers, there's governance, etc., all happening on the relay chain. The goal, and we saw this yesterday in the RFC, is to actually make parachains for governance, make parachains for staking, make parachains for transfers, so that the relay chain itself, the only thing it does is to secure parachains, right? If there's a bunch of activity with staking, a bunch of activity with balance transfers, it shouldn't affect the parachain throughput. This is one of my criticisms of something like Ethereum with L2s. L2s are absolutely affected by all the other activity of Ethereum. You really can't solve these kinds of things on a single chain. When you have a single chain, all activity is affecting one another, right? When you have parallel sharding, that's when you can actually start scaling a network. Current and future system chains. So there's the Asset Hub, Collectives Hub. The Collectives is where all the fellowship members are. They're all in the Collectives in their own parachain. Bridge Hub, and even in Cointer. And Cointer is actually like a third-party team, not Parity or whatever, that has built a chain trying to provide proof of personhood. So this is some kind of identity system, but they don't have their own token. They are only using DOT, and they're providing what we think that Polkadot will think is a common good for the world. So in fact, we gave them a free parachain slot, right? And their runtime is actually in this runtimes folder with the fellowship. But this is really mostly managed by a third-party team. So that you can think of the idea. Like if you're building a functionality for Polkadot only using DOT token, it could be that you get a system parachain slot. And in the future, staking, governance, eventually everything. And then of course we have market bot parachains. So anyone with a great idea and access to the DOT token can launch a parachain on Polkadot. That's the vision, right? That if you have DOT token and you have a great idea, you can write some code with open source software and launch it. And dozens of teams around the world have already done that and are taking advantage of the features that Polkadot provides, right? There's different kind of ecosystem verticals in the space, right? So this is not an exhaustive list, but here are some of the things we've seen show up in Polkadot. Smart contract chains, DeFi, DeSo, so decentralized social networks, decentralized identity systems, tokenization of real-world assets, gaming, NFT, bridges, file storage, privacy, and much more. These are all use cases which are reasonable to build, and we've seen people start building in the Polkadot ecosystem. Right, more. Sorry, any comments? I mean, of course, there's going to be many more ideas that you can have here. You can add to it, but maybe you can even think about what we don't want is just one gaming chain. We don't want just one bridge chain. If you think that one of these verticals aligns with you, redundancy in the ecosystem or optionality in the ecosystem is very good, right? So there's room for many teams to succeed in each of these verticals. Wallets. We have many different wallets in the ecosystem, right? So thanks to the treasury and the Polkadot community, we've been able to fund many teams to rebuild wallet systems. And this is very different. So one of my experiences when I took the Cosmos Academy was that they basically, I went in, they gave me one wallet, the wallet opened up, it took me to Osmosis for trading, and it was just like, exactly, here's the winner, here's the winner, here's the winner. I think same with Solana, with other stuff. I think we have seen some natural winners show up in Polkadot, but it has not been because we chose them. It's because the community has decided it. And in fact, we support and continue to fund many different wallet ecosystems throughout our economy, right? It is important that wallets is as free and open to build on as anything else. Ledger support with metadata. So we are working right now. I think it's already been launched. Ledger is a very common hardware wallet used in the ecosystem. And it is very hard to scale the ledger to work with this modular upgradable blockchain, right? Like we want to upgrade our blockchain as frequently as possible, but Ledger has this kind of cold storage information about what it knows about the blockchain. So we've been working with them actually to provide our metadata in some kind of Merkleized hash such that we can dynamically use a ledger even though the blockchain is updating all the time. And this technology works for all parachains. So we actually are, again, using some very clever technology and some very clever engineering, and using the fact that most of the parachains in the system all use Substrate, to then make integration to things like Ledger so that every single parachain works out of the box, every single Polkadot system works out of the box, and that as it upgrades, it automatically works with the Ledger. It stays up to date. This saves a lot of money in the long term for Ledger support. Yeah.
There's been some criticism about Ledger being like not truly cold,
Oh yeah,
connected to the
yeah,
cloud,
true.
etc. Yeah, one second. Like, so this feature that you just talked about, like, I think kind of like inherently means like somehow connecting to the cloud or something. Like, I'm not sure. No, it's all on chain.
Everything here is happening. So in this case, you can have an old ledger, and with this new metadata update, you should be able to plug in your old ledger into the latest updated blockchain, and the blockchain can provide Merkle proofs for the metadata of that chain, such that when you go to the ledger, it says, I'm doing transfer of 100 dot, you know that's correct.
Okay, like yeah, details.
But I guess I would say this, Ledger and every other wallet has their own flaws, their own point of whatever. We right now are working with Ledger because I think we had a team that was helping us. I don't know if we have a team helping us with like Tezos wallet. What's the other wallets? Other wallets, whatever. But if you're someone who can do that, you can get treasury funding for that. No problem, right? Build these systems. Okay, block explorers. There's a lot of different block explorers out there. Also, so we fund them. Polkadot.js in some ways is some kind of explorer. Polkascan, Subscan, DotScan. Again, we're not trying to pick one winner again. We use the treasury to fund many protocols, making our system more resilient. We do not want one single point of failure, right? Now, some of these systems may just get more natural adoption. That's fine. But the treasury can fund all of them and work. Governance dashboards, you have PolkAssembly and Subsquare. These are also things that are the most popular at the moment. Again, multiple tools doing the same thing. Again, I would say this. Truthfully, if you're a newcomer and you're coming to Polkadot ecosystem, this is not great. It's not great that, oh, I don't know which one to use, what's the difference, all that kind of stuff, right? But the philosophy of being resilient means that we need to support and not just choose one winner, right? So it's kind of on us to maybe create more documentation or to create more easy to understand tutorials or videos on how to use these different tools, but we want to support multiple of them. We don't want to pick one winner, right? The Polkadot forum is a great place to communicate and reach out to people in the community. It's a lot of activity there. There's all these different categories. So maybe you're more interested in the tech talk sections. Maybe you want to avoid things like, I don't know, miscellaneous, whatever. You can go ahead and do that. But I'm on the forum a lot. Activity on the forum is really good to get things up to date. There's a fellowship. We talked about that already, so I'm going to skip over these slides. The RFCs and stuff. And one last thing I want to show you before we end here. I want to show you on the forum a post. Again, talking about ecosystem. I want to share a post. This is a little bit shilling. I'm not going to lie. But I have a post here which is trying to collect ideas of where Polkadot is a leader in the blockchain ecosystem. So I think this is we talked about the Polkadot ecosystem. What about the broader blockchain ecosystem, right? So Polkadot does have the number one most active, or the number one most active devs after Ethereum, right? This is proven year after year that we have the most dev activity. Now, I agree, you probably could use some more activity in other places, but if you're a developer and you want to find the right home, Polkadot's a pretty good place for it, right? We have a very high Nakamoto coefficient. So actually go to Nakaflow. Yeah, this is on the forum. Yeah, I'll put a link to this in the forum. But Nakaflow, an error has occurred. Or maybe it's blocked here. But anyway, as I mentioned, in the talk about NPOS, because we have this NPOS system, we are able to really take advantage of our validators and create high Nakamoto coefficient, which means this number basically means that we have very high resiliency for any individual actors to attack the system. So it would take 82 individuals to collaborate together to attack Polkadot. And 82 is approximately 1/3 of 300, which is the number of validators. So we have basically 1/3 resilience, the Byzantine fault tolerance on the system. So this is quite good. This is compared to other systems which are much, much lower. Yes, go ahead.
Is this number real in the sense that each account is associated with a single entity, or do you know what I mean?
So you're right. In that context, there could be multiple validators with pools. But in that situation, it's actually not about the validator being an individual entity, but actually the stakers behind them. So it's about distribution of the staking pool. So if a validator is doing something negative or bad, or if there's accumulation of a validator getting a lot of money, stakers should put their money in other places. So when we're looking at the perspective of a core, or of a validator as an individual entity, we really think of it as a person who runs the node, but also a bunch of stakers behind them. And that whole entity, about 1/3 of them need to collaborate, which is about as best as you can do with a Byzantine fault tolerance, right? So again, this is thanks to NPOS. Okay, so this again another article showing the same information that we have a much higher Nakamoto coefficient against others because of our system. Here's a table. What is this table? I guess the table of including Ethereum of Nakamoto coefficient. That was after staking. Okay, some more things. We've been recognized not only as the most secure chain with the Nakamoto coefficient, but also the most green chain. That the cost to actually run an individual node as being a validator is quite low. And again, this is because we made decisions like we choose standard hardware. We choose hardware that's approachable and is not like a supercomputer, right? And we also use things like Rust and WASM, etc., to make our code very efficient. So this is a third party determined that we have the lowest impact in terms of a validator, running validators and securing networks, but we still have the most security, right? This is technology. This is a separate source saying the same thing. Look at this thing. Jesus. All right. We're talking about scalability, long-term scalability. Next, execution time. I showed this already in class, right? But execution time of our code much more efficient in terms of pallets than smart contracts, right? So when you're thinking about writing your application, building an application-specific chain is going to be much more efficient than building a specific contract. That being said, the overhead of building an app chain is also quite high, right? You have to launch collators, you have to get a parachain slot. I'm not saying that it's one-to-one comparable, but in terms of speed and scalability, pallets are way up there. Yeah, this is basically when I go to this forum, we'll be done. There's conversations here. I talk about my argument on certain stuff. This is a breakdown of Bitcoin, right? So Bitcoin, they have these hash pools, but practically speaking, we think Bitcoin is very decentralized. I would argue mostly it is, but practically speaking, these hash pools, which collect all the hash power, there's only a few entities needed to get to that 33%. And really, there's like 66% is controlled by 1, 2, 3, 4, 5. Like it's, Bitcoin has its own problems. Ethereum has its own problems too. So, what else? This is another report showing that Polkadot is the number 2 in developers after Ethereum. What else here? Full-time developers again. What's this one? This is more developer activity. This is sub-ecosystems. So I guess this is number of sub-ecosystems within Polkadot. What else am I doing here? Compared to open source things, blah, 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 etc. So that's one example. So I just want to give you even a broader picture of some of the things that we succeed in. So, okay, you're right. Maybe Polkadot doesn't have the most meme coins, right? Maybe it doesn't have the most whatever you're looking for. But there are places where Polkadot really succeeds. I think that I actually like these kinds of metrics much better than other things. And I think that time will eventually recognize, high quality technology and high quality decision making, right? I think the last thing I would say here is, Polkadot is not running a sprint; it's running a marathon. Things may look very different today than they will look in the long term of things. Okay, that's what I hope. Last question before we have to go to lunch.
Two questions, right?
Okay, yeah, sure.
Yeah, sure. Okay, yeah, I just want to comment one thing and ask one thing. I think yeah, he asked like how can we capture the large market? And you said like we should aim to capture new frontiers, right?
That's
And
my personal opinion.
Exactly. And one thing is like as I said there, like maybe we don't have meme points and stuff, but we can be frontier and maybe block space provision and actually be the monopoly in that area, right? But also one thing is I think as the best tech, having best tech is a really good thing, but also I think in terms of leadership, okay, this I know it's a philosophical question in terms of leadership in decentralized ecosystem, in a way that we have seen people need to also to be aware of that best tech and
Right.
to try and to be hooked up, right? Because and I think a role of leadership and someone to like you know, you guys have more advantage, like you, Gavin, and Robert, like in terms of being more visible so that new people can actually see leader are actually more active,
Right.
and people can even have just you know what, I can try to use Polkadot, you see,
Right.
and maybe they can be hooked up into the best technology. But before that, even if you are best tech, people won't know if there's best tech.
I totally agree. So let me say this. My time is valuable to me. Gav's time is valuable to him. We're both here at the academy. We're here talking to, you know, the 100 of you that joined this thing. I think what we are realizing with our time is that, at least in the current day, it's not to get on a stage and shill some coin to a bunch of people who are degens. It's to talk to people who are like-minded and understand this stuff and allow you to get the tools to build the future that we imagine, and then for you to be the voices that can amplify our ideas, right? I spend time to teach you philosophies of Polkadot so that you can echo those into your world. So, you know, I think there's nothing, actions speak louder than words. I'm here on this stage. I've been talking for a long time. I think that the value of my time is talking to you all, right? So